Hi guys. Okay, so my name's Milton-Barker. I'm a founder of a company called Tech Bubble Technologies, and I'm also an Intel software innovator. So I'd like to thank NIT for inviting me to talk today, and Peter Ma and Pooja. And I'm going to talk about how I believe artificial intelligence and biohacking will play a major role in the future of IoT, and how I use these technologies in my own projects, and also my journey as an Internet of Things developer. So just a quick warning, I am actually talking from home, so you may be in danger of seeing a wild dog or two walking around in the background, but they should be okay. So first off, I'd provide a bit of a background on how I got involved in technology development and innovation. I've been a developer for around 14 years, and I'm involved in quite a few areas of development, such as web, mobile and Facebook applications, the Internet of Things, biohacking, and also I've recently begun to develop brain-computer interface applications. So most of my early days in the development world were spent building websites and business administration systems, Facebook applications for businesses. My passion for technology actually began when I was building websites to promote my DJing events when I was a DJ, and it sort of grew from there. I was totally self-taught up until a couple of years ago, but now I have qualifications through taking MOOCs online, such as Harvard, MIT, Stanford and Columbia, on computer science, machine learning and the Internet of Things. And I'd really recommend those courses if you're interested in those subjects. And a lot of the courses are free as well. So what is the Internet of Things? Well, for a number of years I've been writing and talking about the fourth industrial revolution, a revolution that's basically brought about by advancements and integration of numerous disruptive technologies. I believe that the Internet of Things is the backbone of the technologies involved in the fourth industrial revolution, and kind of the glue that holds it together and lets all of these amazing new technologies communicate with each other in an autonomous manner. So there's billions of devices that will soon be connected to the Internet of Things, including sensor nodes, security systems, medical systems, cars, and eventually even humans. So here's a really cool Intel video which demonstrates just some of the amazing ways that IoT will be used to enhance our lives and the world around us. Okay, so up until 2014, I'd never even heard of the Internet of Things. Then one day I came across an advert for the Microsoft Developer Program for IoT, and Microsoft was looking for project ideas and were giving away development kits, which included an Intel Galileo Generation 1, running on a stripped down version of Windows. So I decided to take the plunge and submitted my project idea for an IoT security system that included computer vision to identify intruders. So this project is actually still going, and a version of this project won us the Intel Experts Award at the IoT World Congress Hackathon last year. So a couple of months later, I received an email from Microsoft, which was easily one of the best emails that I'd received at that time. My project had been accepted and I was awarded with the dev kit. The email was really encouraging as well, and it was really good, a good feeling to receive such a great email supporting my idea. It really made me excited to get involved with the project. And it was not long after that I'd become hooked on the Internet of Things. Whilst waiting for the Microsoft kit, I purchased another Intel Galileo so that I could work on projects using both Linux and Windows. So the project is now known as TAS, which is the Tech Bubble Assisted Security System. And it was to include a live stream from an integrated webcam using OpenCV, facial recognition, assistance from TOA, which is the Tech Bubble AI online assistant, and it had sensors like proximity, sound and heat sensors, all controlled by the ARC GUI, which is a central control panel for modern technologies that I've been developing for a number of years now. So I was actually involved with artificial intelligence before the Internet of Things. So it felt like a natural process for me to integrate my IoT projects with AI. And my experience had mainly been conversational AI, but combining existing AI projects with IoT devices and learning about and integrating computer vision seemed like a really cool project for my first IoT development project, so that's what I worked on. So one of the places where I found a lot of help and support when I was first getting going with IoT was the Intel community forums and Intel Developer Zone. So I was immediately attracted to what's known as the Intel Black Belt Developer Program and the Intel Software Innovators Program, and I did as much as I could to interact with that community to build up my reputation. Little did I know that 3 years later I would be presenting this talk to you guys as a member of the Intel Software Innovators Program. But I'll go into more detail about the Intel Software Innovators Program and my journey so far later on in my talk. But for now, here's a quick video that introduces the Intel Innovator Program.
One of the best things about working with Intel is the embrace of open source software as a fundamental component to all of the work that's going on. And that's really, really compatible with all the things that are happening in the computer industry in general. It really shows that Intel gets it.
So when Intel asked me to do a live coding session, this was the perfect time to see if I could bang out a game really quickly. And it allows me to test all the technology that I have and see if I can make something that quick.
This is the face control of the wheelchair, that you can use facial expressions to control the wheelchair without sensors on your body. This was our main motivation, especially for people who cannot control the joystick, but the people cannot control, using facial expressions, but eye track moving, head movement, and speech recognition. So those are the features we are building using the Intel RealSense technology.
When the game starts, you reach in, move the sand. We're using sand from a sandbox with cutting-edge technology with the Intel RealSense. We're excited to be here and develop this game, and we're looking at several different use cases, and we're pretty stoked because this technology is amazing.
I'm doing 2 different demos using Intel RealSense for a smarter car. First one being anti-snoozer. It's detecting whether the driver is drowsy and in turn warns them to wake them up. The other one is a smarter bumper sticker. So when other people are tailgating you, he would show off different type of bumper stickers to show them off.
Hello, so this is Shape Song. It's an interactive music experience in room scale VR where you can build music with you and other people. Making a game in VR has actually been a lot different from building a game outside of VR. We've actually found we want to be inside VR while building it, so making little changes, moving things around, actually creating things while the headset's on.
We connect anything to everything, meaning that it's system APIs, microcontrollers, smart devices, and wearables to build very easy automations for home, office, and industrial IoT technologies.
We decided to use Intel RealSense long-range cameras so we can scan the tall objects, we can scan humans, and the resolution is enough for our business needs.
It's using the Intel RealSense RGB and depth stream to compute an image for people with limited vision or visual impairment so that they can get a better sense of their surrounding environment.
This is Rover, an interactive, gesture-controlled autonomous mobile robot that's using cheap off-the-shelf components, such as a laptop that everybody has, in this case an Intel Ultrabook, for computer vision, for path planning, for perception of its environment. And then with gestures, I can influence its mood. I can turn it into a sad robot, showing a thumbs down gesture, or I can turn it into a happy robot like that.
Innovation goes hand in hand with the maker community, in my opinion. It's just running headlong at a problem and seeing what solution you can think of, whether you've completely thought it out or not, and taking that as a potential idea. There's a quote hanging up in one of my classrooms that says, innovation is seeing what others have seen and thinking what no one else has.
So, about the evolution of IoT through artificial intelligence and biohacking. So, as I mentioned earlier, I was already involved with AI before I began to get involved with IoT. So, integrating AI into my projects was a no-brainer for me. But as the IoT has grown over the last year or so, more and more developers and companies have adopted the idea of using AI to enhance their IoT products and services. Mostly up until recently, the focus has been on AI to analyse the masses of data that is collected from connected devices and sensors. Machine learning is a massively popular tool used for this type of application, and more innovative uses of machine learning in the IoT are emerging. For me though, my focus was more on integrating computer vision and natural linguistics into the Internet of Things, both actually on the devices themselves and on the applications used to monitor and control the devices. So here is one of my latest videos which demonstrates using Arc and TOA, which I mentioned earlier, the control panel and my artificial intelligence assistant. And this demonstrates controlling a number of IoT devices I've created, which uses the TechBubble IoT Jumpway, which is my own IoT communication platform as a service, which is used to allow IoT devices and applications to communicate autonomously. Okay, so as many of you probably know, towards the end of last year, Mark Zuckerberg released a demo video of his artificially intelligent smart home that he'd been building. What some of you might not know is that last year I was also developing an artificially intelligent smart home. I developed the majority of it from the bottom up. I developed the communication platform, which is the TechBubble IoT Jumpway, which allows the devices to communicate with each other autonomously. It allows the AI to communicate with the devices, and it allows the applications to communicate with the devices and the AI. I also developed the devices for the demo myself. The very basic prototypes at the moment. On the top left we've got a temperature and humidity sensor. On the bottom right we've got the entry sensor for doors or windows. We also have the Raspberry Pi artificially intelligent video camera, which can see through a connected webcam and identify people that it's being trained on. And then from my other demo videos, the IoT connected light, which can be controlled via the IoT. So what I'm going to do quickly is give you a quick demonstration of the application and me interacting with the artificially intelligent agent to control and monitor my smart home. Can you tell me if I left the small light on in the office, please?
The small light in the office is on and has been since 9:32 today.
Can you turn the small light off in the office, please?
The small light in the office has been switched off.
Okay, thank you.
A-okay.
What is the temperature in the office?
The latest reading from your TTM device in the office is 38.00 degrees at 9:37 today.
Did I leave the front door open in the office?
The front door in the office is closed and has been since 8:17 today.
Is the front door in the office open?
The front door in the office is open and has been since 9:37 today.
Okay, thank you.
No problem. TOA voice recognition system is now deactivated.
Okay, so just a few quick examples of some of the new features. The voice recognition in the web browser still isn't spot on yet. We're actually working on our own ASR at the moment, but at the moment we're using the WebKit speech recognition API. So there's going to be more demos, more devices and things to come, so that's part of my artificially intelligent smart home. Okay, so during the last few years I've continued to work on the TAS project whenever possible. Just before I attended the Intel and Microsoft IoT World Solutions Hackathon, my landlady's apartment had been broken into, and she asked me if there was anything that I could build to help her become more secure. So this was a perfect opportunity to spend more time on TAS, as this is exactly what I designed it for in the first place. During the hackathon, I joined up with a team of developers and we built a deep learning neural network on an Intel dual development board. And the project also included a smart home prototype with the idea of using computer vision directly on the dual to communicate with the smart home as it identifies people or intruders. The team was very proud to receive the Intel Experts Award for this project, for being the first people in the world to ever build a deep learning neural network on an Intel Dual, which was really cool. So after the event, I teamed up with a couple of friends that I'd met through Harvard X CS50X course, which is Harvard's online computer science course. And we continue to work on the TAS project. So the project so far had used OpenCV and what are called HAR cascades to identify known people and intruders. But after my experience with working with machine learning on the Dual, I decided to look into machine learning frameworks that would allow me to build a machine learning program for computer vision directly on a Raspberry Pi. So on Christmas Eve, as the rest of the world was waiting in anticipation of Santa Claus, I was knee-deep in code implementing TensorFlow version of Inception v3 model, which is one of Google's computer vision models, directly onto the Raspberry Pi, which was what we were using at that time for the project. So before Christmas morning came around, I'd not only managed to successfully achieve this, but I'd also been able to implement transfer learning directly on the Raspberry Pi And transfer learning basically trains the final layer of the neural network to allow for easy and quick training of models that you can then use for computer vision. So as far as I know at that time, nobody had ever done that before. I couldn't find anything online about it. There was no documentation about it. So I think we were one of the first people to do that as well, which was really cool. So here's a video that I made that morning. So this was Christmas Eve / Christmas Day. Okay, what I'm going to demonstrate quickly is the new capabilities of TAS, our artificially intelligent video camera. Initially we built this using OpenCV and a one-layer neural network that uses Haar cascades to identify a person. There was a few issues with that. It wasn't always identifying who the person was every time. In fact, it was actually quite hard. Most of the times when we did demos, we were lucky that it actually did identify at the right time that we were recording. So over the last few days, what I've been looking at is TensorFlow, and more specifically the Inception V3 model. And it's possible to retrain the final layer of the network with less images and requiring less computational power. So this is quite a good thing to have done, because we've actually done this on a Raspberry Pi. As of yet, I haven't found any examples of anybody doing this on a Raspberry Pi. In fact, the person that created the installable version of TensorFlow on the Raspberry Pi told me that it would probably crash, but it hasn't. So what's happening now is, as you can see, it's identifying me every single time. The other issue that we had with the previous version was that the prediction stage it was around about 15 to 20 seconds to actually identify, and like I said, it wasn't always identifying. But if you can read the text on here, it's identifying me every single time that it sees my face, which is a massive improvement, and it's going to push us forward very, very quickly with the progress. And again, this is done on a Raspberry Pi. This isn't done on a GPU, it's done on a CPU on a very low computationally powered device. So I'm very happy with this. Okay, so after further testing of the system, I realized that although it would identify somebody that it had been trained on correctly, it was also identifying people that it hadn't been trained on, but identifying them as one of the people that it had been trained on. I later found out that this was actually a common problem at the moment, which is known as the open set recognition problem. But this led us to our most recent version of the project, where I've been able to solve this issue through the use of an unknown class and using a different framework and a local server for the artificial intelligence. This project is now being integrated with Intel technologies also, so we're replacing the local server with an Intel IoT gateway. So the use of biohacking in IoT. I'd been interested in biohacking and had spent quite a lot of time researching into the subject, and I saw a very big opportunity to begin developing IoT devices that could actually communicate with the human body. This idea really took hold of me, and before I knew it, I had ordered my first implant from a well-known biohacking company, which is dangerousthings.com, and that's run by my friend Amal Grafstra. He's probably going to laugh at me for still not being able to say his surname properly yet. It was really hard for me to find someone that was willing to do the implant for me here in Spain. So eventually I took the matter into my own hands, and I implanted the microchip into my own hands at home. I definitely do not recommend this to anyone. I could have easily done a lot of damage to myself, but luckily everything went okay. And a few years later, there's no problems with it, and I'm able to use it in my projects. So at the time, I was involved in 2 IoT-based competitions. One of them was the IBM Global Mobile Innovators Tournament, and the other one was the Microsoft and Arduino World's Largest Arduino Maker Challenge. So my project for the Arduino Maker Challenge included both AI and the microchip. I used the microchip in conjunction with an NFC scanning device, which is near field communication, which allowed me to communicate with an artificially intelligent Windows universal application that I'd developed to identify myself and allow me to log into the system. So I didn't have to use a password. I also had a fingerprint scanner built into this project as well, but in the demonstration that you'll see in a moment, I used the microchip in my hand. In the IBM Global Mobile Innovators tournament, I got through to the semi-finals of the Smart Home category, and in the Arduino Maker Challenge, I was one of the first phase winners of the competition. So here's a video demonstrating my Arduino Maker Challenge entry, which shows me using my microchip in my hand to authenticate onto the application. So for my competition entry for the Hackster Arduino Microsoft World Maker Challenge, I developed 3 devices and a Windows Universal application that can communicate with those devices. The main device on the project is this one, which is built on the Maker 1000, which is Arduino's currently unreleased development board. I've got hold of one of these from being one of the phase 1 winners from this competition. So just on the left, you can see behind that white wire, that's a temperature sensor there. There's also a proximity sensor and magnetic door switch. So in the real world, this device would be next to a door, and it would be able to detect when people walk up to the door. It would be able to detect whether the door is open or not, and also allow monitoring of the temperature in the area. This device sends the sensor data to Azure IoT Hub. It also acts as a server so that the Windows Universal application can connect to it, read the sensor data, and also update the thresholds for the proximity sensor and the temperature sensor. And over here are the other 2 devices. They're both developed on Arduino Unos. One of them is an NFC scanner, and one of them is a fingerprint scanner, and they communicate directly with the Windows Universal application via serial, and they provide an alternative form of authentication. So instead of using the password feature, you can actually scan a chip or your fingerprint to get access to the application itself. So here you can see on the right hand side, you can see the real-time data coming from the Maker 1000. And you can see on the left the Windows Universal application. I've got them split screen. So the Universal Windows application includes weak artificial intelligence, which is powered by SIML, which is Synthetic Intelligent Markup Language, and that's very similar to AML for all the old school natural linguistics. You remember AML, and SIML's a lot more advanced.
Please choose your login method to continue.
So here you've got 3 forms of authentication. You can use password login, NFC login, or fingerprint login. So what I'm going to do is I'm going to show you NFC, and I'm going to use a microchip that's implanted into my hand just underneath where that brown dot is on the right hand side, and I'm going to authenticate onto the application using that chip that's in my hand.
Thank you. Please select the COM port that your Authway NFC is connected to continue.
So now just need to select which COM port it's on so that the application knows which device to communicate with.
Authway NFC online. Please scan your chip.
So this bit's quite tricky because I'm actually holding the camera in one hand and trying to scan the chip in the other, so just bear with me a second.
Thank you. Please wait. Thank you. Redirecting you to application homepage.
So that's authenticated me onto the application now, and it's loading up, and that's now connecting. You should be able to see a bit more activity on the right hand side. That's connecting to the Maker 1000, and it's retrieved the latest readings. So that's telling me that there's a temperature warning. So it's currently set at 23 degrees, so it's telling me that it's hotter than 23 degrees. So what we can do is we can change the threshold. So let's say 30.
Sorry, I don't know.
And she doesn't understand what I was saying.
Sorry, I don't know.
And that's now...
Sorry, I don't know.
And that's now telling me that the temperature's okay there. So just going back over to the board, if I open up the circuit and move the door sensor and then reload, that now tells me that the door is open. So if I was anywhere else in the world and I was looking at that, I'd know that somebody had just gone into my house. So going back, if I close that again and then reload, that now tells me that everything is okay. Now this application also includes voice recognition, which I'll do in another video to show you that. But that's the basics of the project that I've created and how it works. With the voice recognition, everything that you can do here, so updating the proximity and the temperature readings, reloading the data, you can actually do by speaking to it. The instructions for all of this and the source code is on my project page, which I will put into the link, my project page on Hackster, and also on my GitHub. And once it's all ready to go, which will be later tonight, I'll put all of the links into the description for this video. So earlier on I mentioned about really wanting to be part of the Intel Innovators program when I'd first begun working on the Intel Galileo. I want to finish off this talk with a bit more about the program and an insight into my experience of becoming an Intel software innovator. For a quick overview, to use the words from the official website, the Intel Software Innovator program supports innovative, independent developers who display an ability to create and demonstrate forward-looking projects by providing them with speaking and demonstration opportunities at industry events and developer gatherings. So when I was first approached by Francesco Balderossi, the EMEA manager for the program, it was a really exciting time. I was really happy to be speaking about joining the program. And since I joined the program, I've had nothing but support from the organisers, the staff, and also the other developers. In the short time that I've been an Intel Innovator, I've met some really amazingly talented developers from around the globe. In fact, 3 of us have been involved with speaking in this event over the last couple of days. Myself, Pooja, and Peter Marr are all part of the Innovators program. So that really shows we're from totally opposite sides of the world, and that really shows how amazing the program is for meeting new people and working together with them. I now support Intel events such as hackathons all over the world, where I get to work with Intel staff and also to work with people at the events and help them build their new really cool IoT projects and see some really good things getting created. So, as I said earlier, I really never expected 3 years ago that in such a short time I would be part of the Intel Software Innovators program. But it really does show proof that Intel not only support people developing projects with their hardware and software, but they really get behind the developer community and try to bring their ideas and skills to life. So as an independent developer, I'd like to thank everyone from the program with their support, and would recommend that anybody that's interested in getting involved with the IoT should head over to the IoT section of Intel Developer Zone, which is software.intel.com. And as an Intel software innovator, I'd like to thank all of you guys for listening to my talk. And I hope you have as much fun as I did learning about and developing for the Internet of Things.
Thank you so much, Adam, for joining us.
No problem.
Your work is really inspirational, especially the home automation project.
Sorry, I can't hear you very well.
We love your home automation project.
Thank you.
Thank you so much.
No problem.
Okay.
Okay.
Bye from India.
Thank you. Bye, everyone.